Welcome everybody to the word problem section of linear equations for Unit 5. So let's start with type 1, slope-intercept. So slope-intercept is when it would be y equals mx plus b, aka it's in slope-intercept form. And our note here is that we use this slope-intercept form to start off our word problems when given, or you are given, a rate of change or slope or m and a starting point, which would be your b or y-intercept. So on number 1 here, Evan is going to the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If his parents gave him $20, write and solve a linear equation to find how many rides he can go on. So I think a great thing to do on word problems is to figure out key information as well as defining variables. So here I'm going to go and define our variables. I'm just going to call them x and y like we have been, where x is my independent variable and y is my dependent variable. And our two variables at play are how many rides he can go on, so we're trying to solve for, as well as the amount of money that it costs, because it's $5 to get in and 50 cents per ride, so it's something that can change depending on how many rides you do. So x is going to be the number of rides, while y is the money or the cost associated with the fare and with the admission and rides. And so our slope here in this case is 50 cents per ride, or $0.5. And our b or y-intercept is the $5 it costs to get in for the admission fee. And so we're going to set this up in slope-intercept form, which would be y equals mx plus b, or y equals 0.5x plus 5. And what this means is our total cost would be equal to 50 cents for every ride that you do x, plus $5 to get in. And then we're told in this next sentence, okay, now we're going to use this equation. And said, okay, if his parents give him $20, write and solve a linear equation to figure out how many rides he can go on. So $20, that's going to replace y, and we're going to try and solve for x, the number of rides he can go on. So I'm going to say 20 equals 0.5x plus 5, and I'm going to start solving for x by subtracting 5 from each side. I'm going to get 15 equals 0.5x. Then I'm going to go ahead and divide both sides by 0.5, which is going to give me x equals 30. So that is 30 rides, with labels being very important here. On number 2 here, when visiting Crimson Lake, Sally decided to go kayaking. The rangers charge $8.50 per hour in addition to a $25 deposit to rent the kayak. Okay, we're going to pause there for a moment. So far, we have two variables, once again, and one variable is that the fact that we're charging per hour to rent this kayak. And so one variable is going to be the number of hours, and that'll be our x, where the y is going to be the total amount of money spent on the rental. So our slope, or our m here, our rate of change, is $8.50 per hour, 8.5. And our b, our starting point, is a $25 deposit we have to pay regardless of how many hours you rent. So this would give us our equation y equals 8.5x plus 25. The total cost is equal to $8.50 for every hour that you rent, plus $25 for the deposit. Now as we continue the problem, continue to read, if she rented the kayak from 11:30 a.m. until 2:30 p.m., write and solve a linear equation to find the total cost to rent the kayak. So we're supposed to find y, which means we need to plug in a number of hours. We're told she's renting from 11:30 a.m. to 2:30 p.m. That is 3 hours. So what we're going to do is we're going to take that equation that we just made and plug x in as 3. So we're going to have y equals 8.5 times 3 plus 25. And that's going to give us y equals 25.5 plus 25, which is really y equals $50.50. Moving on to number 3 here, Alex bought a new truck for $42,000 or $42,935. According to the dealer, the truck will depreciate, go down in value, approximately $4,200 per year. Write and solve a linear equation to figure out how many years until the truck is worth $5,135. So write the linear equation. That's what we're going to be doing based upon this first sentence. And so x is going to be the number of years because it's going to depreciate every single year. And y is the value of the truck, which you could put the dollar sign again, but the value of the truck. So our m, or our slope, is how much it's depreciating each year, because that's how much it's changing consistently. And that's going to be negative 4,200. It's negative because it's depreciating or going down. Where b is the starting value of the truck, which is 42,935. So we plug these into our y equals mx plus b, and I get y equals negative 4,200x plus 42,935. And so then, and our second sentence tells us to figure out how many years until the truck is worth 5,135. So we plug that in as our y. And from there, now I start solving for x. So I'm going to subtract it by 42,935. And I'm going to get a negative 37,800 equals negative 4,200x. So now if I divide both sides by the negative 4,200 to get x by itself, I find x to equal, not money, but rather in years, 9 years that it will take to depreciate to that value of $5,135. Next, our last problem for point slope form before we move on to our second type is if you buy a car wash at the gas station for $6, the cost per gallon is $2.35. If you have $40, write and solve a linear equation to find the number of gallons of gas you can afford. So once again, we're going to really use our first sentence in order to make our original equation, where here we have x and y again, and x is the number of gallons that you're purchasing, or y is the cost or the money. And our slope or rate of change is how much you pay per gallon, so 2.35, whereas the b, or the y-intercept, is going to be 6, because that's the car wash at the gas station. And then we're going to find an equation to find the total amount of money you're spending at the gas station to get the car washing and the gas. And so this would be y equals 2.35x, $2.35 for every gallon, plus $6 for the car wash. So now, as we're trying to use the second equation, we're saying, okay, you have $40. How many gallons of gas can you use if you're getting the car wash? And so 40 replaces y, and we start solving by subtracting 6 from each side. And I get 34 equals 2.35x. Now I divide both sides by 2.35. And we get x to be 14.47 gallons, or GAL. And that would be all of our slope-intercept type of problems. Moving on to our standard form type of problems here. Type 2. Standard form reminder is ax squared plus bx, actually not ax squared, my apologies, ax plus bx, by equals c. That's better. Ax plus by equals c. And when you use this, okay, well, you use it when the problem relates two different objects. And you might be saying, Mr. Costle, all of these problems relate two different things, and I would agree with you. All of them relate two different things, but they're all two different objects. So for example, on our last four problems, when we did slope-intercept form, the two things that are related are the variables, and number one related rides and money. Rides are not an object, as in the number of times you ride something. And same thing with number two, and 3 and 4, is that one of them is not an object except for the gallons of gas on number 4. But all the others are an amount of time. So here, for example, we're looking at very much so objects. Sam ordered 2 hamburgers and 3 hot dogs objects from the concession stand at the baseball game. His bill came to $19.05. If the hamburgers cost $5.25 each, write and solve a linear equation to find the cost of the hot dog. So before we know the follow-up information here, we just know the first sentence, or the first 2 sentences in this case, and so we can establish our x and our y. So those are the unknowns. So the x is the cost for a hamburger, so money for the hamburger, you could say. Whereas the y would be the cost for the hot dog, and you could certainly interchange these as far as we're concerned. And so our equation would be you bought 2 hamburgers, so 2 times x, so 2 hamburgers times the cost of a hamburger, plus 3 hot dogs that you bought, so 3 hot dogs times the cost for a hot dog, equals $19.05 that the bill came to. And that'd be your original equation. Then we're told in our third and final sentence, if hamburgers cost $5.25 each, so write and solve the equation to find the cost of the hot dog. So we're going to replace x for the hamburgers with $5.25. So it's going to be 2 times 5.25 plus 3y equals 19.05. So this ends up being 10.5 or $10.50 plus 3y equals 19.05. If I subtract both sides by 10.5, I get 3y equals 8.55. Then if I divide both sides by 3, I'm going to move this over here, I get y to be $2.85 for each hot dog. Moving on to our second standard form problem. Tickets at a school play cost $4 in advance and $5 at the door. Ticket sales for an evening production were $404. Period. Let's stop before we move on. So we're going to establish our x and our y, even just based upon that. And so our x and our y are the tickets purchased at the door. So, tickets purchased in advance, and the other one's at the door. It doesn't really matter which one you call which after, at the end of the day, though. So one is advance and one is at the door. And this would be the number of tickets, because we're already told how much they cost here. And as we look at our last sentence here, that might help you as well, saying how many were sold at the door. So that's something we're looking for here. So this would be 4x, $4 for every ticket sold in advance, plus 5y, $5 for every ticket sold at the door, is equal to 440 total dollars that were made from ticket sales. Now if we plug in that no tickets were sold in advance, that's 4 times 0 plus 5y equals 440. Well, 4 times 0 is 0, so I just get 5y equals 440. If I divide both sides by 5, I end up getting y to equal 88 tickets that were sold at the door. So then on number 7, Karen's piggy bank has all dimes and quarters. The total value of the money of the piggy bank is $11.40. If Karen has 36 quarters, write and solve a linear equation to find the number of dimes she has. So before reading that last sentence, we can even make our equation. And so x and y are going to represent the number of quarters and the number of dimes. And so we're going to have 0.25 times x. I got that from saying a quarter is worth 25 cents, even though it's not explicitly told to us in this problem, plus 0.1 y, because a dime is worth 10 cents a piece. So 0.25 times the number of quarters is the amount of money from our quarters, and 0.1 times y is the amount of money from our dimes. And that would equal the $11.40 that Karen has. Now we're told specifically that Karen has 36 quarters. So we're supposed to find out the number of dimes. So we plug in 36 for x, and I get 0.25 times 36 plus 0.1y equals 11.4, 11.40. And so here, I would go ahead and do 0.25 times 36, and I get 9. 9 plus 0.1y equals 11.40, or 11.4. So I'm going to go and subtract 9, and I get 0.1y equals 2.40. And if I divide both sides by 0.1, I end up getting y to equal 24 dimes, which is how many dimes Karen would have. On to number 8 here. The Oakville High School Marching Band sold gift wrap to earn money for a band trip. Good for them. Solid colored gift wrap sells for $3.50 per roll, while printed gift wrap sells for $5 per roll. The band needs to earn $2,500 for an upcoming competition. So let's pause before our final sentence as we seek to write our equation. So once again, identifying our variable, so x and y, where x would be one of our types of paper and y is the other. So x could be the amount of solid paper rolls that were sold, or y could be the amount of printed paper rolls that were sold. And so our equation here would be 3.5x, $3.50 for a solid piece paper roll, whereas the printed paper rolls are $5 each, so it's 5y. And that's going to equal $2,500 that the band needs to earn for their upcoming competition. Now, if we plug in that the band sold $325 of the printed paper, we need to figure out how many rolls of solid paper they would have to have sold in order to meet their goal. So that'd be 3.5x plus 5 times y, so 5 times 325 is equal to 2,500. So I go ahead and do 5 times 325, and I get 3.5x plus 1,625 equals 2,500. If I subtract 1,625 from both sides, I get 3.5x equals 875. So now I divide by 3.5, and x is 250. So the band would need to sell 250 rolls of solid paper in order to meet their quota if they sold 325 rolls of printed paper. And that wraps up type 2 for standard form word problems. Let's go and look at type 3, point and slope word problems. So this would be using point slope form. Quick reminder, point slope form is y minus y1 is equal to m times the quantity of x minus x1. And our note is that you use this when the problem gives a sample point which would serve as x1 comma y1 and a rate of change which serves as your slope, hence point slope form. So on number 9, at Eagle Bay, it costs $12 per hour to rent a canoe. Nate and his friends rented a canoe for 4 hours and paid $68. Write and solve a linear equation to find the cost to rent the canoe for 7 hours. So we need to know the variables here again, just like we do on each of these. So here, one of our variables would be hours, and that would be x. And the other variable, y, would be the amount of money that is paid. And we also are given our slope, which is $12 for every hour. And we are given an ordered pair that you're sold, that for 4 hours, costs $68. So 4 comma 68 would be my x1, y1. And so now I plug all this in and I get y minus 68 is equal to 12 times the quantity of x minus 4. And I begin solving to get my equation, just like I did in point slope form before. And so I get y minus 68 equals 12 times x, and 12 times negative 4, which would be negative 48. So now I add 68 to both sides, and I get y equals 12x plus 20 as my equation. Now I go ahead and use that equation. I say, okay, now what would the cost have been had it been rented for 7 hours? And so we do y equals 12 times 7 for x plus 20. And 7 times 12 is 84, so we have 84 plus 20. And that would end up telling us that it would cost $104 to rent the canoe for 7 hours. Moving on, number 10 here. A construction company charges $18 per hour for debris removal, plus a one-time fee for the use of a trash dumpster. And we're told the total fee for 8 hours of service was $219. So our x and y here, a big hint on the x and y is that we're told in our order pair we're given the two variables, the hours and the money, the labels on the numbers. So x would be our hours, and y would be the money we're spending. In our order pair, and slope is $18 per hour. The word per does a lot of weight in that, or carries a lot of weight in that. Whereas our ordered pair ends up being 8 hours of service, so 8 is the x, and $219 for the service itself, which is y, and following the fact that we defined x as hours and y as the money that is being spent. And so this would be y minus 219 is equal to 18 times x minus 8. Notice I'm not plugging in using the extra parentheses right now, which is perfectly fine, either way or the other, or one way or the other. And so we distribute the 18, and then we're getting y minus 219 equals 18x minus 144. And so I go ahead and add 219 to each side, and I get y equals 18x plus 75 as my equation. Now, it says now, in the last sentence, we're supposed to write and solve a linear equation to find the one-time fee of a trash dumpster. So if we're doing just the one-time fee, that means we're plugging it in with 0 hours. So y equals 18 times 0 hours plus 75. So 18 times 0 is 0, and 0 plus 75 is just 75. So the one-time fee for the dumpster, for the trash, for the trash dumpster, would be $75. Moving on to our third problem for point and slope form, or point and slope using point and slope form. A company offers premium cable for $39.95 per month, plus a one-time setup fee. Companies are notorious for setup fees there. A total cost for the setup and 6 months of service is $264.70. So this is our ordered pair, and it tells us the two variables are 6 months and $264.70. So x would be our months here in this case, while y is our money that we're spending. And so this ends up being an ordered pair here, or a slope, I should say, of $39.95 for every single month. And then our ordered pair here ends up being 6 months of service, so 6, $264.70 for the y. So now I plug these in, and I get y minus 264.7, or 0.70, equals 39.95 times x minus 6. So this is y minus 264.7, not a negative 264.7, but a minus a singular negative sign there, equals 39.95x as I distribute, minus 239.70. So now I'm going to go ahead and add 264.7, or 264.70 if you will. And I get y equals 39.95 plus 25. And that is my equation. 39.95x, my apologies, plus 25. Now we're going to go ahead and plug in our x value of write and solve a linear equation to find the total cost for 2 years of service. So if we're doing per month, 2 years is 24 months, 12 months in 1 year. And so that's y equals 39.95 times 24 plus 25. So 39.95 times 24 gives me y equals 958.80 plus 25, which results in a charge of $983.80. Number 12 here, a home security company provides security systems for $5 per week plus an installation fee. The total fee for 12 weeks of service is $210. I'm going to pause there to define my variables. So x is the number of weeks, where y is the amount of money. We are charging for the being charged for the service, and those can come straight from our ordered pair. 12 weeks, $210. The label's there. And our slope is going to be the $5 for every week, where our b or y intercept for this would end up being, excuse me, not the b, what am I doing? The ordered pair, that's what I'm looking for, is 12 weeks, comma, $210. So as I plug this in, it'd be y minus 210 is equal to 5 times x minus 12. And so that's y minus 210 equals 5x minus 60. Now if I add 210 to both sides to get x by itself, actually y by itself, I get y equals 5x plus 150. Now I'm going to use this equation to find the cost of the installation fee. So we would run it as $0 per week, what if you just got the thing, and so that'd be y equals 5 times 0 plus 150. And 0 times 150, which means 0 times 5 is 0. Add that to 150, I just get 150. So y would equal $150 for the installation fee. And that would wrap up type 3 for word problems when you're given a point and a slope. Now I'll move on to type 4 here, where we're talking about 2 points. And this is when you're given 2 points, that would be an xy and an xy, x1, y1, and x2, y2, and we'll also be using point slope form here. So we use this when the problem gives 2 sample points as opposed to 1 sample point like last time, and the slope. It's 2 sample points, which would be x1, comma y1, as well as x2, comma y2. And this would be solved the same way you do when you have 2 points in general, which is where you find the slope between the 2 points, and you then use one of the points and the slope to plug it into point slope form and convert that to slope intercept form. So on number 13, to surf the internet for 15 minutes at an airport, it costs $4.05. For 40 minutes, it costs $5.80. Write and solve a linear equation to find the cost of for surfing the web for 1 hour. So defining our variables, x is going to be the amount of minutes surfing the web. where y is going to be the cost for doing so. And the two order pairs we're given are 15 minutes and $4.05, as well as 40 minutes and $5.80. And so we need to first find the slope between those 2 points. So I'm going to do m equals 5.8 minus 4.05 over 40 minus 15. That ends up being 1.75 over 25, which ends up being 0.07. And so now I take that slope and I pick one of my 2 points and I plug this in to point slope form. And I'm going to take the 40 minutes and $5.80 because I like that this is a multiple of 10, and I like that it has a decimal at 5.8 rather than 5.05, the tenths place versus the hundredths place. But if you picked 15 and 405, that'd be perfectly fine as well. So I'm going to do y minus 5.8 is equal to 0.07 times x minus 40. And as I go ahead and distribute this, I'm going to get y minus 5.8 equals 0.07x minus 2.8. Then, as I go ahead and add 5.8 to each side, I'm going to get y equals 0.07x plus 3 as my equation. So now we're supposed to find the cost for surfing the web for 1 hour. So an hour would be 60 minutes. So we put 0.07 times 60 in for x in the equation and add 3 to that. And if I take 0.07 times 60, I end up getting 4.2. And I add 3 to that result. And I found out that it costs $7.20 to surf the web for an hour at the airport. On to number 14, we have water boiling at 100 degrees Celsius or 212 degrees Fahrenheit, and it freezing at 0 degrees Celsius or 32 degrees Fahrenheit. If the weather forecaster says that it'll be 25 degrees Celsius today, write and solve a linear equation to find what Fahrenheit temperature this is. So we have x being degrees Celsius and y being degrees Fahrenheit. And one ordered pair is 100 degrees and 212 degrees for the boiling point of water. And the other ordered pair is 0 and 32 degrees for the freezing point of water. And so we find our slope using this, and we get on the top 212 minus 32, and on the bottom 100 minus 0. So this ends up being 180 over 100, which is 1.8. You can make that a fraction, 9 over 5, which is perfectly fine as well. So I'm going to use the ordered pair 0, 32. I see the 0 there, and 32 being a smaller number, and I'm going to target those numbers. Y minus 32 is equal to 1.8 times x minus 0. So as I distribute, I have the convenience of multiplying by 0, and so I just get 1.8x plus 0, or just 1.8x. So I add 32, and it ends up being y equals 1.8x plus 32, which is the same thing as y equals 9 over 5, x plus 32. And that is the formula that we use to convert from Fahrenheit to degrees Celsius. If you wanted to find out the other way around, for Celsius to Fahrenheit, that is Celsius Fahrenheit, my apologies. If you wanted to go Fahrenheit to Celsius, rather, from y to x, you would have to solve for x rather than solve for y in this scenario. Regardless, you also could have just set it up as x being Fahrenheit and y being Celsius in this problem, by the way. Moving on, though. Now if we're trying to figure out, okay, if it was 25 degrees Celsius, what would that be in Fahrenheit? So we're going to plug the 25 in for x. I'm going to get y equals 1.8 times 25 plus 32. And if I do 1.8 times 25, that ends up being 45 plus 32, which tells me that y is 72 degrees in Celsius. Sorry, 72 degrees in Fahrenheit, because we were converting from Celsius. On the number 15, the value of a car decreases at a constant rate after 3 years. The value of the car is $15,000. After 2 more years, the value of the car is $11,000. Write and solve a linear equation to find the value of the car after 8 years. So here, x would be the number of years that you've owned the car, or the car has existed, where y is going to be the value of the car in dollars. And so one ordered pair is that after 3 years, it's $15,000. I'm going to leave the comma off so it doesn't look like I'm doing multiple points in an order pair, like an XYZ scenario, which would be a third dimension, which we aren't familiar with yet. 2 more years, so that'd be a total of 5 years. The car is worth $11,000. And so we first need to find the slope between those 2 points, which would figure out how much it's depreciating each year on average. And so that would be m equals 15,000 minus 11,000 over 5 years minus 3 years. So that's 4,000 divided by 2 years difference, which gives me $2,000 per year. I should note, oh, whoopsie doopsie, I made a mistake on my I can't find my eraser tool. Well, regardless, I'll just hit the undo button. On my denominator, I made a mistake. I should have had 3 minus 5 because 15,000 was after owning the car for 3 years from that order pair. And 11,000 was after owning the car for 5 years. It doesn't want me to change that 5 for some reason. It's protesting. There we go. Oh, it will only change that. There we go. So now this would actually be 4,000 over negative 2, which is negative 2,000, showing that it's going down 2,000 per year on average. I knew something was off when we got a positive number, because the car does not go up in value. So we're going to plug one of these ordered pairs in. I'm going to pick the one with smaller numbers. For the smaller y value at least, I'm going to do y minus 11,000 is equal to negative 2,000 times x minus 5. So now I distribute my negative 2,000, and I get negative 2,000x plus 10,000. I add 11,000, and I get y to equal negative 2,000x plus 21,000. And now I will go ahead and use that to figure out the value of the car after 8 years. So I plug in 8 for x, and I get negative 2,000 times 8 plus 21,000. Then from there, I go ahead and multiply negative 2,000 times 8, and I get negative 16,000 plus 21,000, which ends up giving me $5,000. On to the next page here, number 16. Customers of a satellite dish company must pay for installation of the dish and a monthly fee for service. After 6 months, Ryan had paid $594. After 11 months, he had paid $989. Write and solve a linear equation to find the cost for the installation. So x is going to be the number of months having the service, and y is going to be the amount of money paid for the service. And big hints there are the labels on the ordered pairs here: 11 months, the money, 6 months, the $sign on the number, so the labels on those numbers are big hints. And one ordered pair, as I mentioned, is 6, 594, 6 months, $594. The other one's 11 months, so 11, $989. And so now as I seek to find the slope between these two ordered pairs, I'll go ahead and do 989 minus 594 over 11 minus 6. And so that ends up giving me 395 over 5 which is a slope of 79, meaning it's $79 per month. So I plug this in along with one of my ordered pairs. I'll choose a smaller one, so y minus 594 is equal to 79 times the quantity of x minus 6 months paying. So y minus 594 is equal to 79x minus 474. So if I add 594, I get y equals 79x plus 120. So now if I'm trying to figure out the cost for the installation fee, that means the cost after 0 months of owning it, but only installing it. And so that's y equals 79 times 0 plus 120. 0 times anything is famously just 0. And so I get 0 plus 120, or just $120 for the service fee. Sorry, the installation fee. And that wraps up 2 points, if you're given 2 points in the word problem. So now we're going to do an aspect where we're going to determine the type of problem that we have. So we're going to have 4 problems, and each one's going to be one of our 4 types. Either standard form, slope-intercept form, going out of order, slope-intercept form, standard form, 1 point in the slope, or 2 points. Now that was actually in order. So Kate here bought $23.40 worth of 2 types of birdseed. Thistle birdseed sells for $1.60 per pound, and wild birdseed sells for 95 cents per pound. If she bought 12 pounds of wild bird seed, write and solve a linear equation to find the amount of thistle birdseed she purchased. So we are comparing 2 items here. We're comparing 2 types of birdseed, the thistle birdseed as well as a wild birdseed. And so one variable is going to represent the amount of thistle birdseed purchased, while the other one is representing the amount of wild birdseed purchased. And we're not given slopes or anything like that, so it rules out slope-intercept form as well as 1 point. And we're not given 2 ordered pairs, being told that Kate bought this much for this amount of money and this much for this amount of money, aka 2 ordered pairs. Meaning that since once again it is 2 items we're comparing to and we aren't given slope or 2 points or anything like that, it must be standard form that we're looking at. So I'm going to go and label this as standard form, which once again is ax plus by equals c. And so this would be 1.6x for $1.60 per pound of the thistlebird seed, plus 0.95y, 95 cents per pound for the wild bird seed, equals $23.40 that Kate bought, or Kate paid. And so that would be our equation. And now we're asked, with that equation, we're supposed to find, okay, so if she bought 12 pounds of wild bird seed, we're trying to find the amount of thistlebird seed. So it's 12 for the 12 going in for y. It's 1.6x plus 0.95 times 12 equals 23.40. So that's 1.6x plus 11.4 equals 23.4. Subtract 11.4. And 1.6x equals 12. Dividing both sides by 1.6. I get x to equal 7.5 pounds, which could be abbreviated LBS. Number 18 here. Jack is keeping track of his weight. Jeff is keeping track of his weight. Good for Jeff. And after 2 weeks, he weighs 194 pounds. After 6 weeks, he weighs 186 pounds. Well, pause. Noticing here, 194, that seems like an ordered pair. 6 and 186, that seems like an ordered pair. So this already is telling me that it is a 2-point type of setup, which was our type 4. So this means we're going to find the slope between those points, and we're going to plug that into point slope form with one of the points. So I'm going to go ahead and start working on that. So x is going to be my weeks, where y is the amount of pounds. And one ordered pair is that 2 weeks he weighs 194 pounds, and the other ordered pair is that 6 weeks he weighs 186 pounds. And so now I go ahead and try to find the slope of these, and I do m equals 194 minus 186 over 2 minus 6. So I'm going to end up getting 8 over negative 4, which this ending up being a negative makes sense because Jeff is losing 2 pounds per week. So I pick one ordered pair to plug in. I'm going to pick the one with the smaller y value because I guess that just sounds better to me. So y minus 186 equals negative 2 times x minus 6. And so that's y minus 186 equals negative 2x plus 12. And so if I go ahead and add 186, I get y equal negative 2x plus 198. And so now we're trying to figure out, okay, what would Jeff's weight be after 12 weeks if he continues this trajectory of losing 2 pounds every week? So we plug in 12 for x after we get y equals negative 2x plus 198. That negative 2x didn't come out very well in the equation. There we go. So negative 2 times 12 plus 198. So that's y equals negative 24 plus 198, which is y, the 1 on 198 didn't go, which is y equals 174 pounds. Number 19, a landscape supply business charges $35 to deliver mulch. The cost of the mulch is $29 per cubic yard. So I'm going to pause there and notice, hey, this is a flat fee, and this is a 29 per cubic yard. That looks like slope, and that looks like a starting point. So this is going to be slope intercept, which is again y equals mx plus b. So here, the m is $29 per cubic yard, and the b is the $35 delivery fee. And so we plug this in, and I get y equals 29 times x plus 35. Because, oh, I forgot to define variables. X would be the cubic yards, and y would be the money spent, the cost. And so that would be our equation. The cost is equal to $29 per cubic yard plus $35 for delivery. Now we're trying to figure out, okay, write and solve the linear equation, which we did, to find the cost of having 6 cubic yards of mulch delivered to the site. So we wrote the equation, and now we're going to solve it for 6 cubic yards. So we're going to plug in x for 6, x as 6, y equals 29 times 6 plus 35, which ends up being 174 plus 35, which is $209. On to our last problem. The process of elimination tells us that this one's going to be a 1 point. Let's find out. Haley used a birthday check her mother gave her to start a savings account. She plans to save $25 per month as well. So that looks like an M for $25. Take note of that. And after 9 months, Haley has $300. Well, there's our ordered pair, 9, 300. So this is, in fact, a 1 point problem. We're going to use the point and the slope. Now it is important for us to know what x and y are, where x is the number of months, and y is the money being saved. So I plug this into point slope form, and I'm going to get y minus 300 is equal to 25 times x minus 9. So as I distribute my 25, I end up getting 25x minus 225. And if I add 300 to both sides, we get y equals 25x plus 75. And now we're trying to figure out the original check amount from Haley's mother. So that'd be after 0 months of additional savings. So y equals 25 times 0 plus 75, and 0 times any number is 0, and 0 plus 75 is 75. So Haley's mother wrote the check for $75. And that wraps up all of our word problems from Unit 5.